Hello. In this assignment, we'll be using unsupervised learning methods to analyze and identify the most important features in a binary classification problem. Here I have imported the data set. We'll be using a water quality data set. So totally 9 features are present and portability is a target variable and we have it in a binary format. So to determine it, we'll be using feature extraction and feature selection methods ahead. First, we have to analyze our data. We have 3276 rows and 10 number of columns. So in this pie chart, we can see the target variable portability, which contains 0, which has 61 percentage, and 1s, they have 39 percentage. And the distribution of rows and zeros is 1998 and 1s is 1278. Then we have to pre-process the data. So in this matrix, we can see the missing values in the features, the 3 features, pH, sulfate, and trihalomethanes. So we can take median, we can replace those missing values. Next, we have to analyze the data distribution. In the histogram and density distribution of the feature space, we can see some data points are out of the normal distribution, like in solid features. We can notice that is slightly skewed. So, after detecting it, we can eliminate those outliers, so we'll have better data points for our algorithm. So now our number of rows is reduced to 2666 and the columns is 10. So initially it was 3276. So and the target value of 0 is 63% and 1 is 37%. And before going into further steps, we have to standardize our data. Then for feature extraction, first we are using k-means to reduce the feature space. It computes until it finds the optimal centroid and the data points are assigned to it by calculating a small distance. So using the k-means function, that the inertia value tells us how well a data set is clustered. So the lower the values of inertia is, the lower number of clusters will be a good model. Then we have plotted number of 2 clusters. So in the scatter plot, we can see 2 features, which is pH and the hardness value, with the centroids are displayed. So with the number of clusters with k values 2, 3, 4, and 5, we got the results of how much of data samples we correctly labeled and accuracy value. So among these, when k value is 2, we have the high accuracy score of 0.50. We can also find optimum number of cluster by using elbow method and silhouette method. So in this plot, we can observe there's a small bend. It is known as the elbow point. It is at the number of cluster 2. So this way we can find the optimal k value, and also even in the silhouette method we give the range of clusters and it will predict. So the cluster 2 has the highest score. By applying both these methods, we found that the optimal number of cluster is 2. Next, by performing PCA with the given extracted features, we can find the accuracy of the model. PCA can be used to perform dimensionality reduction. For the feature F value, when it is 3, we can see it has an highest accuracy among the others, although there isn't much striking difference, and it does not give the underlying distribution of values to help with what kind of error our model is making. So we can use confusion matrix. So the 4 outcomes would be true positive, true negatives, false positive, and false negatives are also calculated. And in this plot, we can see the number of extracted features, with 3 has the highest accuracy score. Then we can observe that the accuracy of k-means and the PC accuracy value is 0.5. Next, for feature selection, we're using random tree. So by using the random forest classifier, we could see the feature importance of each feature displayed, and the random forest accuracy score is 97% for estimators of 10 decision tree. So now we can just visualize. So we have plotted all the features in the descending order. So as the least is conductivity with a point, the score of 0.10. So I have taken a threshold of 0.11 so that we can just eliminate the least important features and keep the highest scores, and then also perform and measure the accuracy. So by taking the threshold as such, we get only 3 features among the 9, and then after performing the accuracy with the important features, it is again 0.97. With all features, it's again 0.97. It isn't much of difference. So from this we can observe the accuracy is not affected by selecting only the significant features in this case. Perhaps we can only use these features instead of all features and save computational cost. So whereas the accuracy value of k-means and PCA values are the same as zero point 0.5 and the random forest is 0.97. So because it is a non-parametric, which means it will not make assumptions about the underlying data distribution, whereas k-means and PCA are parametric, which is contrary to that. So therefore, among all the 3 methods, random forest classification method gives the best results. Thank you.